லிங்க் ஒன்று போடுறேன். நான் நேவிகேட் பண்ணும்போது அது மட்டும் மாறுதான்னு மட்டும் பாரு. ஓபன் பண்ணிட்டியா? பிரசன்டேஷன் தெரியுதா பாரு.
இதுல பிரசன்டேஷன் தெரியுது.
தெரியுதா யூடியூப்ல?
யூடியூப்லயா?
கொய்யால இதுல எல்லாருக்கும் தான் தெரியும்.
நான் உங்களுக்கு ஒரு லிங்க் அனுப்புறேன். அதுல யூடியூப் தெரியுதா பாருங்க. மெயில்ல அனுப்புறேன். அந்த யூடியூப்ல தெரியுதா தெரியுதா? மெயில் அனுப்பிருக்கேன். நேத்தே எனக்கு அவர் அனுப்புனது. எனக்கே யூடியூப் எடுக்க மாட்டேன். யூடியூப் வருதா? மேம்க்கு தெரியுதாம்பா, எனக்கு தெரியல.
பிரசன்டேஷன் தெரியுதா?
பிரசன்டேஷன் தெரியலமா? இல்ல நான் அது அவரோட இதுல போட்டுருங்க. அது நான் பண்ணிடுறேன். இன்னும் அவங்க லிங்க் யாருக்கும் ஷேர் பண்ணல. உங்களுக்கு மட்டும் தான் பண்ணிருக்கேன். அதை கேட்டேன். மேம்க்கு தெரியுதாப்பா. என்ன கன்வல்யூஷன் நியூரல் நெட்வொர்க் தெரியுதா?
ஸ்கிரீன் மூவ் ஆகுது தெரியுதா பாரு.
ஸ்கிரீன் மூவ் பண்ணுங்க. மூவ் பண்றது தெரியுதா? எனக்கே என் லேப்டாப்ல எடுக்க மாட்டேங்குது. அந்த ஜன்னல் கிட்ட போயிருங்க. அப்போ அங்க தெரியும். நீங்க ஏன் தேவை இதுல நான் போடுறேன். எனக்கும் கேட்க மாட்டேங்குது. தெரிய மாட்டேங்குது. ஸ்கிரீன் என்ன பண்ணிருக்கீங்க? எம்டிஆர் இருக்கு. ஓபிஎஸ் தான் காட்டுது.
வர இப்போ தெரியுதா?
நான் பாக்குறேன்.
வெயிட் பண்ணு. திருப்பி ப்ரெசென்ட் பண்ணுறேன். வெயிட் பண்ணு. என்ன தெரியுது? ஹலோ? ஹலோ? யூடியூப் இதுல உன்னோட மீட்ல தெரியுதுன்னு பாரு வைக்கணும். கூகுள் மீட்ல அதுலயே வெளியே வந்தேன். Oh, image recognition works. Oh, image recognition works.
இதுலயும் தெரியுது. இதுலயும் தெரியுது.
பிரசன்டேஷன் தெரியுதா?
ஆ.
கிளாரிட்டி கரெக்டா இருக்கா?
நல்லா இருக்கு. ஜிமெயில் தான் நம்ம யூஸ் பண்ண போறது இல்லையா? யூடியூப்ல தானே ஃபுல்லா போட போறோம்.
கூகுள் மீட்டே யூஸ் பண்ண போறது கிடையாதா?
ஆஹா, எதுக்கு?
அப்புறம் எப்படி நீங்க ட்ராக் பண்ணுவீங்க?
இதுலயும் தெரியுது.
பிரசன்டேஷன் தெரியுதா?
தெரியும்.
கிளாரிட்டி கரெக்டா இருக்கா?
நல்லா இருக்கு. ஜிமெயில் தான் நம்ம யூஸ் பண்ண போறது இல்லையா? யூடியூப்ல தானே ஃபுல்லா போட போறோம்.
கூகுள் மீட்டே யூஸ் பண்ண போறது கிடையாதா? லேக் இருக்கும் இல்லையா? லேக் இருக்கும்
அப்போ கூகுள் மீட்டோட பழைய மீட்டும் போட்டு இதையும் போட்டு விடுறதா?
இல்ல போட்டு ஃபர்ஸ்ட் 100 பேர் வந்து இதுல ஜாயின் பண்ணுங்க, அதுக்கப்புறம் மத்தவங்க எல்லாம் யூடியூப்ல ஜாயின் பண்ணுங்கன்னு போட்டுற அவ்வளவுதான்.
அப்படியா? சரி, அப்ப நான் நேத்து போட்ட லிங்கே போட்டுறேன். இந்த யூடியூப் லிங்க் மட்டும் இப்ப கொடுத்து விடுங்க.
வெயிட் பண்ணு. லிங்க் ஏதாவது மாறுதான்னு பாக்குறேன். அப்படி இல்லைன்னா நம்ம இதே போட்டுடலாம்.
இப்போ நம்ம கொடுத்தாதான் எல்லாரும் ஒன்னொன்னா ஜாயின் பண்ணுவாங்க. ஜிமீட் போக மீதி இருக்கவங்க அப்படியே ஜாயின் பண்றது கரெக்டா இருக்கும். ஏன்னா நாங்க மெயில் போடணும், 300 மெம்பர்ஸ்க்கு மெயிலும் போடணும்.
வர ஒரு நிமிஷம்.
ம்.
லிங்க் மாறலதான் நினைக்கிறேன். சரி, ஓகே, அனுப்பிச்சு விடு.
சார் இதுவா? இந்த வர சார். இந்த
happy வரலன்னு உனக்கு படம். Welcome, sir. Sir, can you hear me, sir?
Yeah, ma'am. Good morning, ma'am.
Good morning. Welcome, sir.
Good morning, sir. Chandran, sir.
Hey, good morning, sir.
Yeah, welcome, sir.
Start by 5 minutes, madam. Okay, ma'am. Okay, ma'am. Yes, sir. Yes, sir. Okay, sir.
Yes, ma'am.
No, 5 minutes start பண்ணலாம் sir. நம்ம.
Sure, ma'am.
Happy morning, sir. Sir. Venkit, sir. Sir, can you hear me, sir?
Yeah, ma'am. I can hear you.
Thanks for joining, sir.
Thank you, ma'am.
Okay, sir, we start, sir.
Shall we start, ma'am?
Yes, sir, yes. Sir, switch on your video, sir.
It's a small issue,
Lekya ma'am, you
madam.
also switch on the video.
A small issue, madam.
Okay.
Yes, ma'am.
You can switch on the video, ma'am, everybody. Please.
Shall I start, ma'am?
Switch on the video, please.
A small issue in my end, ma'am.
Okay, sir. Okay.
Yes, ma'am.
Okay, sir. You can proceed, sir.
Yeah,
No
thanks.
issue.
Good morning to all of you. I feel honored to welcome our today's resource person, Mr. Chandran Venkatesan, Senior Data Scientist in the Math Company, all the participants and my fellow colleagues for taking a keen part in 5 days international STTP on advanced approaches and insights on artificial intelligence and deep learning in healthcare. It's a great pleasure for me to introduce our speaker today, Mr. Chandran Venkatesan, who is going to interact with us about diagnosis of specific diseases using deep neural network. Mr. Chandran Venkatesan is working as senior data scientist in Math Company. He has more than 5 years of experience in executing data-driven solutions to increase the efficiency and utility of data processing. He has experience at creating machine learning models using predictive data modeling and analyzing data to deliver insights and implement action-oriented solutions to business problems. He has received MA degree in VLSI design in the Government College of Technology, Coimbatore, and submitted his PhD thesis in Anna University under medical image processing. He has published 40 plus research articles in various SCA, Scopus, and Web of Science journals, conference proceedings, and also contributed book chapters. He has published a book, Brain Computer Interface Using Deep Learning Applications. He has also delivered more than 50 plus lectures to wide variety of audiences. His research interests include VLSI, signal and image processing, deep learning, and artificial intelligence. He has published 10 patents in India. He is an active member in various professional societies like ISTE, ISRD, ASR, IAENG, AIML Society, and IFERP. He is an NVIDIA certified instructor for deep learning, for computer vision, and fundamentals of deep learning. So, with this great technical profile of the resource person, Mr. Chandran Venkatesan, I am sure that you all will feel enriched with the knowledge after completion of today's session and hope that you all will have a great time ahead. I welcome you, sir, once again to the STTP, and now the stage is yours. Please.
Thank you, sir. It's audible to everyone.
Yes, sir. It's audible.
So, so let me know once you can able to see my screen. Then we can get started.
Yes,
Yes,
sir.
sir. It is visible, sir.
Okay. So, good morning, everyone. Those who are attending this 5 days STTP on advanced approaches for different ML and deep learning algorithms. Okay. So, in today's particular topic, we are going to discuss about some fundamental understanding of how these convolutional neural networks is working, because as this HTTP is mostly focusing on that healthcare problem. So I will be focusing on like how we are going to solve some of the healthcare imaging problem using a different convolutional neural networks. So for this, for that particular uh, fundamental building block to work with the convolutional neural network is to understand what exactly as a mathematical point of view, the convolutional neural networks work, because there are a number of convolutional neural networks that are available in the current scenario. It starts from the year of 1990, where the Professor Jan Kuhn has proposed the first CNN based architecture called LeNet architecture. So from that, there are a number of different types of advanced deep learning architectures by having the backbone of convolutional neural networks. So whenever we are discussing about a convolutional neural network, the one thing is that we need to understand the fundamental mathematical behind this convolutional neural network is nothing but a convolutional property. Okay, so that is very much important. So I will discuss in brief that why we are only considering the convolutional property, why it is useful for a neural network, neural networks, and then how we are going to solve different imaging applications using the CNN. So yeah, before getting into topic, did anyone know about what do you mean by convolutional neural network? What are these applications? So if someone know the answer, you can just unmute yourself and then. Okay, so I'll discuss about briefly. Okay, so before getting into the how the convolutional neural networks work, like first we need to understand how this image recognition works. Okay, so let us take an example. I have an image. Okay, so image as a human perception of seeing that particular object through eye, then we are calling that as an image. So image is nothing but it is a two-dimensional data which having x and y coordinates. Okay, so each and x and y will have some pixel values. Okay, so this is put together, it's called a two-dimensional signal. Okay, basically the image is nothing but a two-dimensional signal. Okay, so we have the image data. We are going to recognize, okay, so in the given object whether that particular image contains a bird or not. Okay, so for this type of typical applications, which is called also called as image recognition or image classifications, we can say a different naming for this particular application. Okay, so but do you know how deep learning algorithm recognize the object in an image? So basically, if you take this particular bird image. Okay, so as a human, we are seeing through a human eye, so we can able to see, okay, say this particular image as a bird. But if you want to make the computers, or if you want to make a system to understand that given image is a bird image, or it may be a cat image, or it may be a truck, or so basically all these images will be stored as a binary values. Okay, so all these images will have a pixel values of zeros and one. Then only the digital system will able to understand what exact data that present in that particular object. Okay, so if I replace this entire image with the zeros and ones, even the humans can't able to answer that, okay, whether this is a bird image, or this is a cat image, or this is the truck image. Okay, so we need some visualization to understand, okay, so this particular image contains a bird, cat, or whatever it may be. Okay, but if you want to make the system to understand, okay, so the given object is a bird image or car image or truck, then we need to make sure that this particular image is converted into a digital format. So whatever the images we are storing in your mobile phone, your laptop, it all may be as a binary value. Okay, at the back end data, it should be in the binary values only. Then how does a convolutional neural networks helps to recognize this image? Okay, so basically if you take any neural networks, there are three layers. Start with the input layer, hidden layer, and the output layer. So before getting into the neural networks, okay, so how the convolutional neural network has been coined, okay, when it has been proposed. Okay, so what is the biological inspiration of a convolutional neural network? Okay, so the biological inspiration of convolutional neural networks nothing but our human brain. Okay, so however our human brain is works like how the human brain is getting the signal, how it is processing that signal, and how that signal has been converted to some of the some of the action, right? So let us take an example. I met my friend last week. Okay, so while you are seeing your friend or while we are visiting your friend's house, so some of the actions we are taking, like we are just remembering, okay, so we spent last 2 years during our college days, we went to some other places and we spent some good amount of time. Okay, we may able to recall, okay, whatever is happening uh, in the past. Okay, so how it is happening, like, so we are passing some signals to the brain, so the signals activate that particular information which is stored in our brain, and then we are recalling that information. Okay, so likewise in a convolutional neural network also we are having some activations. Okay, so we need to activate the neurons to remember such things. Okay, so basically if you I don't know how many of you from the biological background, so if you have gone through any human brain mammalian diagrams, so there is a three different points will be there, like they may be noted as v1, v2 and v4 on the human mammalian diagram. Okay, so if you have time, just go and search for that. So similarly the v1, which is called, which is a human brain, which will help us to receive the low signal. Okay, the signal may be between 0 to 20 milliseconds, but I'm not know the exact number, but it should be the range of 0 to 20 milliseconds or 0 to 20 nanoseconds. Okay, so this v1 point will be able to capture the low informations, low signals. So similarly, if you take a convolutional neural network, we are having a three different layers. First we will discuss about the low level layer. So low level layer is nothing but in the given object, it will help us to understand, or it will help us to extract all the edges and corners. Okay, because edges, corners are the low level information in the given image. Okay, so let us move to the human brain diagram. So in human brain diagram we are having the another point called, which is noted by v2. Okay, so v2 will help us to capture the signal between 30 milliseconds to the 80 milliseconds. Okay, so it will gather the information with somewhat high intensity. Okay, so likewise if you take the convolutional neural network, we are having the mid-level layers which are capable of understanding what the shape of that particular object. Okay, if I have the the given bird image, it will try to extract all these edges and corners, the low level as a low level feature. If we go to the mid level features, it will try to understand, okay, so this is the eye, so this is the peak, this is the wing. Okay, so it will try to understand each and every object from the given image. So move to the human brain diagram, we have the point v4, which is placed at the back 8. Okay, so that v4 point is a more sensitive point. So once the information reach that v4 point, then it should not be removed or erased from our human brain. So that's what whenever we fall down on some any of the accidents happen, then they will check whether anything happened to the back portion of your head. Okay, because this back portion of the head is the where our v4 point is there. If something's happened to that particular point, then maybe we end up with a memory loss or coma, so whatever it may be. Okay, so v4 is a more sensitive part. So likewise in the convolutional neural network, we have the eye level features which will give the exact picture replica of your given image. Okay, so first level we have edges and corners. In mid level we are having giving the objects, giving the shapes to the different objects in a given uh, for a given image, and then in eye level features we are having the exact replication of image, but as output we don't end up getting the same view of the given image, but we will get end up with a feature map. Okay, so whenever you are passing any input or any signal to the convolutional neural network, the output is nothing but a feature map. Okay, any doubt up to this?
No, sir. Please proceed, sir.
So this is what I have been discussing. Like, okay, if you take a given image as a pixel, we will have some different values, ranges from 0 to 255, because the most of the applications we are dealing with the RGB image, where each of the channels will ranges from 0 to 255. So basically, it is 256 grayscale value of each red, green, and blue. But as we are working with the Python index starts from 0, so it will have values from 0 to 255. Okay, so this is what we have discussed that. So we have an image. So in the input layer we are passing each and every pixel in the form of array, and then we will have some filters. Okay, so filters will help us to do the convolution operation between the given input signal and the filter. Okay, so we are having a different filters. Like if we want to redact the edge, we have the edge filter and we have the Sobel filter, and then we have a pitwise filter, and then we are having a good number of filters. But we need to decide which filter we need to consider to get the feature map out. But the beauty of using the CNN is that we don't need to give much focus on these filtering operations. Okay, so convolution will able to handle, or so in convolution the filter is nothing but the weights. Okay, so it's a weight matrix in the convolution. Okay, so this weight matrix will automatically updated by using the different algorithms. Okay, we will discuss about what type of algorithm we are using to generate this weight matrix. Okay, so once we have the weight matrix and once we have the input, we will just convolve it in input and output, and at the end we will end up with a feature map. Okay, so there are multiple hidden layers. Like we have the convolution layer, we have the ReLU is nothing but an activation layer, and then we have the pooling layer. So all these extra different layer will help us to perform the feature extraction. Okay, so that is one of the difference between the machine learning and deep learning. Okay, so yeah, I need answer from someone that what is the main difference between the machine learning and deep learning? Any idea?
Deep learning need big data.
Deep learning need big data. Okay,
Deep learning automatically extract the features from the given input image
okay, how it's doing?
by using convolution operations and max pooling.
Okay, yeah.
Whereas in machine learning, we need to manually extract the features.
Yeah, that is the exact answer I need. Like if you take the machine learning, the feature will need to extract manually. Okay, so maybe we need to write a feature extraction program, or we need to write the feature engineering program to extract the features from the given data. It may be a text data, or it may be a image, or it may be a video, audio, whatever it may be. But the beauty of using the deep learning algorithm is that so deep learning is have the capability of extracting the features on its own. Okay, so that's why this CNN or convolution property is one of the important property uh, in the aspect of a deep learning algorithms. Okay, so in deep learning algorithm we don't need to do a manual extraction, so automatically your convolution layer will take care of all this sort of feature extraction stage. Okay, so then so once we have the convolution operations where we do this convolution operations, then we will move to the ReLU layer. So ReLU is nothing but it is the activation layer. Okay, so if you take the activation layer, so we are having a different set of activation layer. Basically why we need activation layer. Okay, so let us take an example. So if we have any sort of action that we need to take. Okay, so let us take an example. I want to move from my place to Bangalore. Okay, so if I want to move from my place to Bangalore, then I need to take some action. If I want to take some action, definitely my neuron in the human brain should fire. Okay, if neuron doesn't activate, then I can't able to move from my place to, at least I can't able to walk 10 meters if my neurons is not firing or my neurons is not responding. Okay, so basically in the convolution also we need to activate that particular neurons by using the activation functions. Okay, so basically the activation functions whatever we are using, like we have the sigmoid function, we have the softmax activation functions, we have the ReLU, and then we have the leaky ReLU, and then we have tanh. Okay, so basically we can start with sigmoid and softmax. So basically if you take sigmoid and softmax, these two particular activation functions will be used only at the output of the convolutional neural network. Okay, so if you take sigmoid, so whenever we are doing any binary classification, let us take an example, simple example, like I want to classify a given image whether the given image contains dog or cat. Okay, then I can make use of this sigmoid activation function to classify this process. Okay, let us take an example, another scenario, like I want to classify cat, dog, and then mm, tiger. Okay, then take any one animal as an example. Okay, if I want to do this 3 classification, then I will not able to do with the sigmoid, because sigmoid the ranges between 0 to 1. Okay, so either the sigmoid 0 means it is a negative class, uh, or positive class. Okay, that is the only thing I can do with sigmoid classification. So basically, the sigmoid activation function will be used for a binary classification. But if I want to do the multi-class classification, like an example, I have proposed that cat, dog, and tiger, then I need to move with the softmax. Okay, so the softmax will give each class probability of prediction. Okay, so but if you take sigmoid will give either the positive class or the negative class for the probability prediction, but the softmax will give a probability prediction across the classes. Okay, so that is the advantage of using this softmax function. And then if you move to another activation function called relu. So relu, sorry, first we can discuss about the tan h, then we can move to relu. Okay, so relu is nothing, tan h is nothing but it is the tan hyperbolic function. Okay, so tan hyperbolic function is another activation function, the values which ranges from -1 to +1. Okay, so this is also widely used in binary classifications, or if any one of you worked with any LSTM or GRU network, you can able to see this TANH activation function in the hidden layers. Okay, so basically the TANH activation function is widely used in the text processing. So that's why our any sequencing part like LSTM or GRU models, you can end up with seeing this TANH as activation functions. And then we have another activation function which is called a ReLU. So ReLU is nothing but it is a rectified linear unit. Okay, so this is one of the most prominently used activation functions when compared to the convolutional neural networks. Okay, so the advantage of using the ReLU is that instead of having the boundary range between 0 to 1 or -1 to 1, this ReLU will have the range of 0 comma max. Okay, the value will start from 0 and it will end up with the maximum pixel value or maximum value whatever we are getting as the output from the convolutional operation. Okay, so that is the advantage of ReLU. Okay, so can someone say what is the drawback of using ReLU? So I will explain that the equation of ReLU is function of x equal to max of 0 comma x. Okay, so that is one fundamental problem using the ReLU. So can someone tell that what is the problem using the ReLU?
For negative values, it gives 0 as the
Okay, what will happen
for
if it
positive.
gives 0?
Oh, so we cannot learn for negative values of in
Okay,
neural network cannot learn.
okay, okay. So any other answers? This is right. Yeah, there is another problem is also there. Anyone can want to try? Yeah, so basically one thing is it can't able to learn the negative features, but there is another problem is this relay will end up with making the neurons to die. Okay, so if you are making that value of this particular neuron equal to 0, then there will be no learning will happen, right? So this makes there is a problem of dying neurons or dying neurons in the ReLU activation function. But when compared to the performance level, even though the neurons values become 0, it is not having that much impact on our overall performance. But if you want to improve the overall performance, we can go to the different varieties of ReLU. Like, so we have the leaky ReLU, where the function would be like function of x equal to max of minus 0.1 comma or 0 point minus 0.1 z comma x. Okay, so this minus 0.1 that we can decide. Okay, so if you want to do minus 0.1, and otherwise if you want to consider this minus 0.1 as another parameter, then you can go to the parametric ReLU. Okay, you can let the algorithm to learn what that particular value should be. Okay, either it should be the minus zero point 0.1 or it may be minus 0.01 or it may be minus 2, minus 5. So this particular value will be learned by the algorithm on their own. Okay, so these are the different varieties of activation functions we are having, considering a convolutional neural network. Okay, so I didn't go in depth, like we have the soft plus activation, we have the soft sign activation. So we are there are some different activation functions also there, but most prominently these are the widely used activation functions as far the CNN is concerned. And then we have the pooling layer. So basically the pooling layer is used to downsize, or used to reduce the dimension of the image. Okay, so I will show that how the dimension of the image will help us to reduce the computation power. Okay, and then if you are not using the pooling, what will happen? Okay, so we can discuss that in the later part. And then finally, once we have this convolution pooling and then convolution activation layer and then pooling layer, then final layer is your fully connected layer where you are ending up with getting the probability of each of these class. Okay, so any doubts in the overall process of CNN? Any doubt from participants? Whether am I audible to everyone?
Yes, sir. Yes, sir.
Okay. Yeah. So we can move to discuss about the in-depth of CNN architectures. Then we can eventually move to an hands-on part once we complete this. Okay. So first, there is so much of debate is happening across the globe, like who is the father of deep learning or who is the father of convolutional neural networks. Okay, so if you take who is the father of deep learning, so without a doubt, Jeffrey Hinton. Okay, so Jeffrey Hinton is the father of deep learning, and then Jan LeCun, and then Joshua Bengio, and then these are the folks who are also the part of making this deep learning a big success. Okay, so we'll discuss about the Jan LeCun. Okay, so because Jan LeCun, who is proposed this CNN architecture in the year of 1990. Okay, so where he have first proposed a linear architecture, which is help us to classify or recognize the handwritten digits. I think most of you, those who are familiar with the deep learning, our baby data set is handwritten digits. Okay, so I think most of you have worked with that particular data set. So he's the director of Facebook AI Research Group, and then he's the one who built this linear architecture and linear that based on the convolutional neural network in the year of 1988. It was first used to recognize a character recognition task like reading the zip codes or digits. Basically, this is handwritten data set. Okay, he's the one who proposed this linear architecture, which have the backbone of convolutional neural network. And then uh, I think after that also there is no progress, that much progress happened across this CNN, but in the year of 2014, like where the student of Jeffrey Hinton, who is called Alex. So Alex proposed a first very big neural network called AlexNet. Okay, I hope most of you are aware of AlexNet. Okay, AlexNet is the first CNN architecture that take a place in ImageNet competition and won the competition also. Okay, basically every year there may be they will conduct the ImageNet competition where we need to categorize or we need to classify thousands and billions of classes. Okay, so the the modern networks like AlexNet, GoogleNet, and then we have ResNet, DenseNet, and then we are having efficient net. So all these nets are basically participated in this ImageNet competition, and they have won this competition. Okay, so that is the advantage of a convolutional neural networks. So all these architectures are take a part in ImageNet competition and won the competition. Okay, so this is an intro about intro about Yarn Lekun. Okay, so we can move to the convolutional neural networks. Okay, so the CNN is a feed-forward neural network that is generally used to analyze visual images by processing the data. Okay, so if you want to work with the signal, you can convert that signal into the image, and then we can make use of CNN architecture to work with that. Otherwise, if you want to work with the text, then we need to make use of the 1D convolutional neural network to process the text data. So basically, if you take CNN is a feed-forward neural network which is used to analyze the visual images by processing the data with grid-like topology. So this, yeah. So if you want to discuss about the convolutional operation, so I hope most of you are aware of convolution operation, right? Can someone tell uh, what is symbol to represent convolution and what is the difference between the convolution and multiplication? Any answers from the participants? Any thought process around what is the difference between multiplication and then convolution operation? Anyone from the electronics background? I think most of you spend so much of time in this convolution property. We start with mathematics and digital image processing, signals and systems. Any thought process?
You'll be shift and do the multiplication till the end of the image is reached.
Okay.
First row wise will be shifted till the last row is reached. Then
hmm
column wise will be shifted. Then row wise will be shifted and do the multiplication.
Okay. Whether it is not possible using the matrix multiplication, simple matrix
Yeah,
multiplication,
yeah,
we can
that's
able to do
possible,
that.
sir.
Yeah. But
Yeah.
then what is the difference between normal multiplication and then the convolution operation? So how many of you know about equation of neural network? Equation of neural network? Any idea, guys? So let us take a basic example. What is the equation of linear regression? Any answers around this? What is the equation of straight line?
Straight line y is equal to mx.
Yeah. So if you take a straight line equation, okay, this is very similar to the equation of neural network. Otherwise, we can name it across. The neural network equation is very similar to your straight line equation. Okay. So for straight line equation, we have y equal to mx plus c. Similarly, for neural network, that equation is y equal to wx plus c or wx plus b. Okay. So y is your output, w is your weight, and x is your input, and then b is your bias. Okay. So by considering this equation, okay, so if we want to perform y equal to wx plus b, then definitely in the given equation we need to do both a multiplication and then addition. Okay, so this convolutional operation will help us to do that. Basically the convolution operation is will help us to do the dot product, and then it will end up with adding that values. Okay, so that is one of the advantage of using the convolution operation, and also there is a couple of characteristics, as a couple of properties that convolutional operations will brings into the plate is that we have the local connectivity, like each and every neuron from the previous layer will be connected to the neurons in the next layer. And then there are another concept called parameter sharing. Okay, so this particular neurons from the previous layer to the next layer will be sharing these parameters across all the neurons. Okay, so these are the two big advantage, or two big uh, characteristics of using a convolutional neural network. Okay, so yeah, so this is what we have discussed, like the convolution puppet is nothing but doing the dot product of a and b, and then computing sum of the product. Okay, so yeah, so this is how the real image looks like, and then how it be represented in the form of image, and then our form of black and white pixels, and when it is converted into the binary values, then this is how this image will look like. Okay, so if you want to work with the CNN, so this is the image will pass into the model, but the model will interpret that given image in the format of 0 and 1. Okay, so can someone, we can able to see by considering the zeros and ones, say that okay, this is a smiley symbol. We can't able to tell that, okay, because we don't know how this sequence of zeros and one is present in the given image. Okay, so the layers in the convolutional neural network, or we have the convolution layer, and then basically it is a activation layer, but as we have using the ReLU, we are mentioning ReLU, and then we have the pooling layer, and then we have the fully connected layer. So basically a convolution layer has the number of filters that perform the convolution operation. So let us consider an example. I have the 5 cross 5 image. I need to convolve this particular image given the filter size of 3 cross 3. Then this is your feature map. The feature map is ending up with 3 cross 3. Okay. So how this convolution operation will be working like, so if you take first 3 cross 3 pixel. So the first 3 cross 3 pixel is 1 1 1 0 1 1 and then 0 0 1. Okay, so we need to first pass these 3 cross 3 pixel values into these filters. So if you apply a dot product over here, so you will end up with getting value, some of the product value is 4. Okay, so basically the equation to determine the output of this particular operation is that, so n minus ef, yeah, so n minus f divided by s plus 1. Okay, so n is your number of rows in the given image, like, so here the number of rows is 5, so, and then f is the number of rows in the filter. Basically the output equation is will be like, so n minus f by s plus 1 comma n minus f by s plus 1. Okay, so n is 5, 5 minus 3 is 2, and then plus 1, you will end up getting a 3 cross 3 here. Okay, so I think there is some queries in the chat. Okay, so let me open the Jamboard. So let me know if I can able to see my Jamboard. You guys able to see my Jamboard, right?
No, sir.
Okay, so let me share it again. I hope now we can able to see my Jamboard.
Yes, sir.
Okay,
Yes,
so
we can move.
basically, if you take the equation of neural network, this is y equal to, sorry, so y equal to w, so x plus b. Okay, so w is nothing but your weight and x is nothing but your input value, and then b is your bias. Okay, so this is how a general neural network equation would be look like. Okay, so if you want to convolve a given image with a filter, then that equation would be like n minus f divided by s plus 1, similarly comma n minus f divided by s plus 1. Okay, so n is your nothing but number of rows in your input image, and f is the number of rows in your filter, and then this n is the number of columns in your input image, and this number of columns in your filter size. So s is nothing but the stride. Okay, so how much step we need to uh, move your given window slide to compute that. Okay, so any doubts in this equation? Like if you take that image, I have 5 cross 5 as an input image, and then filter size is 3 cross 3. So then you will get 5 minus 3 equal to 2. So let us assume that s equal to 1. Then you will be getting 5 minus 3 divided by 1. So you will end up getting 2 here, and then 2 plus 1 is 3. So your output equation would be 3 comma 3. Okay, so any doubts with respect to this equation? Okay, so let me know once you can able to see my uh, deck, yeah, PPT. Are you able to see my PPT?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yeah, thank you. So yeah, this is how this convolutional layer will work. Like the equation, there is some uh, simple modification that will happen in the equation whenever we are including that concept of padding, and then yeah, and then concept of strides. Okay, so I will discuss that in later, like, but mostly that equation would be like similar to this only. There is a slight modification we'll need whenever we are including the concept of padding and then striding. Okay, so yeah, these are the different filters. Like this horizontal filter used to find the horizontal lines or horizontal edges, and then we have the Sobel filter and score filter. Okay, basically if you take convolutional neural network, so this filters would be like typically a weight matrix. Okay, so this weight matrix will automatically estimated by using the different algorithms. I will explain that in detail. So every image is considers a matrix of pixel values considering the following 5 cross 5 image. Yeah, so this is an example I want to show. Like first, if you can take the first 3 cross 3 matrix and then convolve with this given filter. So 1 into 1, 1. So 1 into 0, 0. 1 into 1, 1. So at first row you will be having 1 plus 1, 2. And if you take second row, we are having a 2 zeros. Only 1 is there. So in second row you will end up getting 1, and if you take third row, so we are getting a 2 zeros and then that is only 1. So if you take add up all the sum values, first row will have 1 plus 1 2 and then plus 1 3 and then plus 1 4. So you'll end up getting the convolved feature of 4. Okay, so if you want to move one straight forward, then you need to consider like this. Okay, so here we are having a first 3 cross 3 and then we are moving one straight forward, and then we are getting this 3 cross 3. Okay, so if you compute or if you do the conversion operation here, so 1 into 1 1, so 1 into 0 0, so 0 into 1 0, and then here also you will end up getting 0. So only the diagonal element you will end up getting 1, because other than everything seems to be either the given filter value is 0 or input value is 0. So you will end up getting the value 3. So then again one step forward, you will end up getting 4, like similarly like 1 and then 1 and then 1 plus 1 2. So you're basically getting a 4 4 3 and 4 as the first row. So then moving the slides at the downwards, here also if you can see, if you do the convolution operation, you will end up getting a 2, and then another one step forward 4, and then another one step forward you will getting 3, and then we need to move the slides downwards, so you'll end up getting 2 and then one step forward and then another one step forward. So this is how the input image is convolved with your filter, and then we are getting the convoluted feature. Okay, so any doubts up to this? If there is no doubts, I can proceed to the ReLU function. Okay, so I'm considering there is a no doubt, so I am proceeding with the ReLU. Okay, so ReLU, as we have discussed, that the equation of ReLU is a function of x or function of r comma z equal to max of 0 comma z. Okay, so either it will have, for all the negative values it will have the value 0, on all the positive value it will take the maximum of the given output value. Okay, so the advantage of using ReLU is itself sets all the negative values or negative pixels to 0, and it is introducing the non-linearity to the network, and then the output is rectified feature map, and it also helps us to do the element wise operation. Okay, so first I think we have discussed most of this, but we can discuss about what is meant by non-linearity. So why we need non-linearity in the given architecture. Okay, so can someone say that what is the difference between the linear and then non-linear function? What are the operations we consider as a linear operation? What are the operations we are considering that as a non-linear operation? Any answers? So you can just relate this non-linear and linear function to your neural network equation. Like, so if you consider the neural network equation, what is that? Y equal to wx plus b, right? So what is the form of this function? It is a linear or non-linear?
Linear only.
Linear function, sir.
Yeah.
Linear.
So if you consider this is a linear function, then you will end up getting a real values, right? The output of this y equal to wx plus b, you will end up getting some real values. Okay, so real value is nothing but it will end up getting some numbers. But what is our ultimate objective? So we are doing the classification here. So we need to make sure that this number is converted to the discrete format. Okay, that's why we are introducing this non-linearity to the model. Okay, so if you take the ReLU function, so here it is mentioning the maximum of 0 comma z, but basically at the background it is doing some exponential function there. Okay, so basically this type of activation functions will do the exponential function, so which will convert that linear function of y equal to wx plus b into the some non-linear function. Okay, so if you want to deal with any I-dimensional data, then you need to move towards the non-linear functions. Okay, so basically if you take image, or if you take text, or if you take a voice, for this type of data which is I dimensional data, then we need to definitely move to the non-linear function. Okay, these activation functions will help us to do that. Okay, so this is the inputs, and yeah, so let us take this is an input image. So after convolving that input image with our filter, so this is what a feature map look like. So you can see, so it will remove all the backgrounds, and you will get only the area that are strengthened where we have the object. Okay, so if you want to fine grind this feature map, then we need to pass into the ReLU activation functions. Okay, so in multiple convolution ReLU and pooling layers connected one after another that carry out a feature extraction in every layer, that input image is scanned multiple times. Sorry, there is some spelling mistake. Okay, so is scanned multiple times to generate a input feature map. Okay, so there may be some question will rise that if I want to create any CNN architecture, what is the optimal number of layers, or what is the number of layers I need to consider to get a better results? Okay, so 100 percentage I'm sure that in the given scenario, or given the research that has been happening across the globe, there is a no thumb rule is there to decide, okay, this is the optimal number of layers, or this is the number of layers I require to create a good performing model. Okay, someone will get or end up with having a deep learning architectures with 100 layers and having the accuracy, or having the model performance around 99% accuracy with very minimum loss, and someone with a different applications have only 20 layers of deep neural network, and they will end up getting a 98% accuracy. Okay, so this all depends upon the business scenario, and then it's all depends upon the data set we are working, and it depends upon the applications we are going to solve. Okay, so there is a no thumb rule there to convey that, okay, this is the optimal number of layer we need to use in order to get a better results. Okay, so it's up to you, or it's up to the researcher or designer to get through some different trial and error methodology, and then come up with a better model with optimal number of layers. Okay, so then is your pooling layer. So basically the pooling layer, I already told that it is basically useful to reduce the dimension of the image, because so whenever we are considering any CNN architectures, the number of parameters to train is very huge. Okay, so these are these technique, like pooling is one technique and dropout is another technique, which will help us to downsize, or which will help us to reduce the number of parameters in the model. Okay, so I have this rectified feature map. Okay, so I have the 4 cross 4, which is output from the ReLU architecture, ReLU layer, and then I am just max pooling pooling with 2 cross 2 filter. Okay, basically the max pooling, how it will work is, so it will take the first 2 cross 2 filter, and then it will take the maximum value and replace the center pixel, and then it will take another 2 cross 2 and take the maximum pixel value, and then it will end up with getting the maximum pixel values. So here also it will take 2 cross 2, the maximum is 4, and it is replaced with 4, and if you take this, the maximum is 7 and it replaced with 7. Okay, so there is a two scenario we need to understand, that why we are doing the downsizing. Okay, so why we need to reduce the dimension of the image. And why we are considering the max pooling instead of, like, we are having a average pooling also, and then we are having a, minimum pooling also, but why are we using max pooling here? Any idea about that? So basically why we are using the max pooling layer is that it will help us to preserve the features or pixel which is give the maximum information. Okay, so I don't want the features with the value of 1 or 2, or with the feature value of 0. Okay, so I will end up in getting a high pixels which are more useful to understand the underlying characteristics of the given image. So that's why we are using the max pooling layer. The second scenario is that why we are using the downsize is, one is that help us to reduce this overall computation power, and then also we will end up getting a good number of features with a variety of features. Okay, so there is two scenario: one is a good number of features and with a variety of features. Okay, so that is the advantage of using the pooling layer. Okay, so this is the uh, identify edges, corners and other features to the bird, and this is how the pooling layer will look like. Okay, so it will give only this exact or high information pixels other than removing all these low information pixels. Okay, so and then the final step after a pooling is a flattening layer. The flattening is nothing but, so you can see we are having a 2 cross 2 matrix, but after or before output layer there should be some fully connected layer, which is a typical artificial neural network. Right, if you know the artificial neural network, so we are having a different set, some set of neurons, and then we will do some processing and then we will get output. So similarly here also we need to have this set, like we need to have some fully connected layer before the output layer to do the computation, to compute the probabilities of each class. Okay, so that's why we are using the flattening. So flattening is nothing but it will help us to convert any high dimensional data to this single column vector. Okay, so that is the advantage of flattening here. So this is the basic pooling layer, and then once we have flattened, so it will be converted into neurons. Okay, so the another advantage of using the convolution is that if you take a traditional ANN architecture, we need to convert that image into the pixel, and then you need to pass that pixel into the neurons. But using the convolution operation, you can do all this different performance by the help of a raw image instead of converting that into the array format. Okay, so you only need to convert that image into array format or vector format at the output. Okay, so but in between that you can do all this convolution pooling and then activation operations with a different set of layers. Yeah, this is how this fully connected layer look like we are having some set of neurons, which neurons is connected to the each and every neuron to the next layer, and then you will be pass that into the model, and at the end you will get the output of a binary. Let us consider this is a 3 class problem, so that's why we are ending up getting uh, 3 number of neurons. If it is a 10 class, you will end up getting the 10 set of neurons at the output layer. Okay, so yeah, dog, bird and then cat. So you'll end up, so this particular image is bird, so it is identified that as a bird. Okay, so if you break down the entire conversion operation, the initial layers is a feature extraction layer, and then the bottom layer is called the classification layer. Okay, so if anyone of you work with the pre-trained model or transfer learning model, so you will end up doing that, freezing the top layers and only training the bottom layers. So yeah, so the bottom is nothing but we can fine tune this fully connected layer, which is called as a classification layer, by preserving this feature extraction from some other applications. Okay, so these are the famous CNN models like AlexNet in 2012, and then ZFNet, and then GoogleNet, VGG16, sorry, VGGNet, ResNet, Inception V3, and then MobileNet. Okay, so I have just only pointed out up to 2017, but so we are having a good number of CNN models like in ResNet itself, we are having a different variety of ResNet like ResNet V50, ResNet V150, and then we have VG16, VGG19, and then we are having the uh, efficient net. On the efficient net also we are having a different varieties of efficient net and different versions of efficient net v0, v1, v2. Okay, so these are the famous CNN model which available in the current scenario. So any doubts with respect to this? So I can take 5 minutes. So if you have any queries, so we can discuss now before going into the hands-on part. Yeah, so the softmax layer will be useful at the output of your CNN architecture. Basically, so if you are dealing with the multi-class problem, so we need to make use of the softmax. So softmax activation function will be useful to perform the multi-class problem, where each class will get up some end up with getting some probability value. Okay, so let us take an example that example we have discussed, like cat, bird, and dog. So at the output, the bird will take 99 percentage predicted probability of bird, and then 0.1 percentage of cat, and 0.9 percentage of dog. Okay, so basically softmax will be useful for the multi-class problem. So any other queries? Yeah, so the relu can be useful for any such applications. It may be a binary class, or it may be a multi-class, but please make sure that a relu activation function will be only used in the hidden layers. It should not be used at the output layer. So basically, the CNN will not differ that much for grayscale and RGB image. The only difference is in the RGB image, the number of filters you are ending up with getting three different channels. One is a red, blue, and then green channel. And if you take grayscale image, you only get one channel, like it is a black and white. That's it. Otherwise, the architecture wise, it's common. Any other queries? No doubts. No, that is not possible. We can't able to give any grayscale image to the color models. Maybe you can convert that grayscale image into any of the color models, and then you can just pass this image into to the CNN architecture. Any other clarification or any doubts regarding the CNN architecture from the audience side? Okay, so considering there is no questions in the chat, I am moving towards a hands-on part. What is the major role of hidden layer in CNN? Like, so most of this feature extraction will be happen in the hidden layer. So nothing will be happen at the input layer and then at the output layer. Most of this feature transformation or feature extraction will be happen in the hidden layers. Basically, the hidden layer is nothing but your convolution and then your pooling layer and then your activation layer. All this comes into the hidden layers.
Sir, good morning, sir.
Yeah, good morning, ma'am.
Sir, I'm having one doubt related with the image, sir. Image
Okay.
part. So, in case of medical image diagnosis, sir,
Hmm.
so we are taking some sort of images like CT scan,
Hmm.
ultrasound images, so on.
Yeah.
So whether so we cannot directly pass that images to CNN architecture.
Hmm.
Shall we pass, or we have to convert to a colored image,
Hmm.
RGB pattern, or directly whether we can
No,
process
we can directly pass that into the CNN model by considering that is a grayscale image.
directly we can. But
Yes.
previously, one member had asked a question whether grayscale image can be directly passed to this model, and you had insisted that we have to convert to RGB, some
There is
color model. Then
no need to convert that into the color model. Okay, so as far as that quality and then the image modality is concerned, we can directly pass the CT scan to the CNN architecture also.
okay, sir. Okay, sir. Thank you.
Any other queries? Okay, so we can proceed with, yeah, so that's a good question. Like, what will be the changes in the output if the padding and then striding values are applied? So let me quickly share my screen. Uh, okay, so basically, if you want to preserve the input size of the image, right? Like we are having the input size image of 5 cross 5, but after doing the convolution operations, we are ending up getting a 3 cross 3 here. But if you want to make sure that you need to preserve the exact shape of your input image, then there is a technique called padding. Padding is nothing but appending the zeros across the boundaries. Okay, so if you append the zeros across the boundaries, then you will end up getting a 7 cross 7 image. Okay, so basically the output will have the padding So 0 0 0, and then you are getting 0 0 0, and you're getting 0 0, and then you're also getting 0. So basically, if you're adding the one layer of padding, you will end up getting instead of 5 cross 5, you will end up getting the 7 cross 7. So 7 cross 7, then the equation would be changed to. So let me open the notepad. That would be. So if you have the padding, then the equation would be changed to n minus f plus 2p divided by s plus 1, comma similarly n minus f plus 2p divided by s plus 1. So here the n is 7 cross 7 after adding the padding, and then uh, f is 3 comma 3, and then stride, I am assuming the stride equal to 1, and then padding equal to 1 because we are appending the padding on. So let me open the excel and then uh, just walk you through that how this padding will be occurring. So let us assume that I have the values like this. So I just randomly fill these values. Okay, so this is your 5 cross 5 input. Okay, so if you want to do the padding, then we need to append zeros across the boundaries. 0 0 0 and then 0 0 and then so basically, so you can color this into different theme. Okay, so this is how the appending will work. Okay, so this is a 5 cross 5 input, but after appending you will end up getting 7 cross 7. Okay, so if you apply the in the equations like n is 7 and then your filter size is 3 plus 2 into 1, because padding is 1, then it will be 2. So divided by s, s is 1, then you will end up getting 1, 1 only, then plus 1 comma 7 minus 3 plus 2 plus 1. So 7 minus 3 is 4, 4 plus, yeah. So 7 minus 3 is 4, 4 plus uh, 2, it's 4 plus 2. Yeah, so you will end up getting, I think, sorry, the filter size is 5. So the your n is 5. 5 minus 3 is 2. 2 plus 2 is 2, and so 2 plus 2 4. 4 plus 1 is 5. So we'll end up getting 5 cross 5. So this is how the padding will help us to preserve the input size of your or input dimension, right? Yeah. And any doubts with respect to this? So this is the equation we need to modify. Okay. So basically it should be like this. So n minus f plus 2p divided by s and plus 1, where uh, number of rows slash columns in input. F is nothing but number of rows slash columns in filter, and then strides padding. Yeah. So this is the updated equation of uh, output of the convolutional layer. Okay. So then we can move to the final part of our session, like the hands-on part. So let me know once everyone can able to see my screen of Kaggle notebook. Can everyone able to see my screen?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So this is the Kaggle platform. I am assuming that most of you know about this Kaggle. So Kaggle platform is nothing but uh, it is the platform which is help us to do some data science project. So basically, it will provide some GPU facility, and then also it will give some TPUs to train our deep learning model. Okay, so basically, it's per week we can make use of 30 hours of GPU and then another 30 hours of TPU. Okay, so this can also support a different types of GPU architectures, GPU devices. So if you go to the accelerator, you can see it is giving around GPU T4 cross 2 and GPU P100, TPU V38 and TPU VM V38. Okay, so these are the different GPU hardware devices which widely used to mm, train the models. Okay, train the deep learning models. So yeah, so basically, what disease we are going to discuss today is that basically a binary classification problem of a diabetic foot ulcer. So so let me open any one of these images and then we can. So, so let me open the image from the folder itself instead of. So let me know if you can able to see the image.
Yes, sir.
Yeah. So this is one of the example of the image with the diabetic foot ulcer. Okay. So how this diabetic foot ulcer is happening, right? Like, so those who are having diabetes, so they are more prone to this diabetic foot ulcer. Okay. So there are different types of diabetic foot ulcers there. So one is due to improper flow of blood through a vessels to the foot. If that is happening, then they will end up getting some blackish area in the foot, and it will leads to the amputation. And also we need to uh, there is another scenario that we need to remove the leg. Okay, so if you want to treat this diabetic foot ulcer, if it is reached very severely, then we need to do the operation to cut the leg of the patient. Okay, and then for some of the patients, if it is not treated, then it will lead to the death also. Okay, so that is the complication of diabetic foot ulcer. Okay, so these are the different visuals of diabetic foot ulcer. You can see sometimes you can sometimes the patients also are having the diabetes. So if they didn't treat this diabetic foot ulcer initially, then uh, the skin will be like you will get up seeing that the foot bones. Okay, so it will just degrade your entire skin, and then it penetrate to the skin, and then we can able to see the bones of the patients. Okay, so this is one of the biggest complication of diabetic foot ulcer. So if it is not treated well, so it will just happen as a small dot, because if you take the diabetes patients, they don't feel this uh, pain. Okay, they don't have the pain in the foots. The patient those are having the diabetes. That's what, if the patients with the diabetes having any of this wound. Okay, so they didn't feel that pain. Okay, even if you eat that wound with very hot, they didn't able to feel that pain. Okay, there is some numbness in the foot, or it may be any of these regions. Okay, they can't able to feel that pain, the patient those are having the diabetes. So slowly this wound will be progressed, and then it will end up getting uh, just damaging the entire nerves, which will also stop the blood flow to the knees, sorry, blood flow to the foots, and then end up getting the limb amputation. Okay, so this is my research area where I'm trying to categorize whether that given image is a normal image or healthy image, because sometimes the healthy image you can see. So this is the healthy image. It's only the problem with, like, there is some skin wrinkles that has been happening at the foot, but it is not diabetes, right? So these are the normal skin patches, and then the previous one I have showed is the ulcer patches. Okay, so basically what we are trying to achieve here is we are going to create a deep learning model. Basically, I'm going to use a pre-trained efficient net model to categorize the given image is a normal image or abnormal image. So first and foremost step, while creating any of these deep learning model, or working with any of the deep learning or machine learning models, to import all the necessary libraries. Okay, so if you take a basic libraries like NumPy, Pandas, computer vision library, and then OS library, and then C1. So these are the basic libraries which is help us to do or help us to perform a different uh, different processor. Like if you take the NumPy, so NumPy is basically it's a numerical Python which is help us to do most of the numerical computation. Okay, so if you take Pandas, you know that it is a tool which is prominently used for all this data structure issue, structure problem. Okay, and also data formatting, all these sort of things will be taken care by the Pandas. And then OS, if you want to access the directory of the given folder or get directory of the project folder, then we need to use OS library in order to navigate to the folders. And then we have the matplotlib. So basically matplotlib and seaborn are the libraries which just help us to do a different visualization. Okay, if you want to do the bar plot, if you want to do the uh, scatter plot, or if you want to do this correlation map, all this will be will be done using these two libraries. Okay, and then we have the import cv2 library. So import cv2 is nothing but it is a computer vision version 2 library which is help us to do different image manipulations like reading the image, formatting the image, or changing the color format, or resizing the image. All this will be happen through CV2 library. Okay, and then we have the scikit-learn. So basically, the scikit-learn is a scientific computing library which will help us to create the ML models or classification report, confusion matrix, and then if you want to do the train and test plate, all this will be happen using this scikit-learn. Okay, basically it's just SQL in the DOM. Okay, so then we have the TensorFlow and then Keras. So TensorFlow and Keras is most prominently used deep learning framework to create a deep learning architecture. Okay, so before 2020, so we have both Keras and TensorFlow as a separate framework, but after that they have integrated these two framework where the front end is Keras and the back end is TensorFlow. Okay. So from the Keras, we are importing a different pre-processing techniques like image data generator, and then we have the activation layer, dropout layer, convolution 2D, max pooling, and batch norm, and also we have the optimizers like Adam and Adamax, and then metrics is categorical cross entropy, and then Keras, we are using the regularizer effect to prevent the overfitting of the model, and then we are importing the models. Okay, so basically I will just give the quick glimpse on that what do you mean by dropout or what do you mean by batch norm, because we didn't discuss this in detail. Like, so if you take the batch normalization, so basically the normalization nothing but if you have any values, okay, like ranges from 0 to 1000, assume that it ranges from 0 to 1000. If we want to confine this particular ranges 0 to 1000 to the particular range of 0 to 1, then we need to do the normalization. Okay, so basically if you consider the image, we are having a 0 to 255. So what we are trying to do is, so instead of having the 0 to 255 as a pixel value, we are going to confine to the particular range of 0 to 1, where the 0 means it's corresponding to the pixel value 0 and the 1 means it's corresponding to the pixel value 255. Okay, so you will end up getting all these values confined in the range of 0 to 1. That's what a batch normalization will be used. Why we use batch normalization is that, one, to improve the overall training performance. Okay, and then it will also help us to improve the training time. Okay, these are the two set of characteristics we are using. We are making use of the batch normalization function, and then we have the dropout function. So I know most of you have been work with a machine learning model or any data science model. So there is a problem of model overfitting, right? So we need to make sure that model is not overfitted for the given data. If the model is overfitted for the given data, then in real time, if you're testing your model will not perform well. So basically, our ultimate objective is to create any data science model or any deep learning model as a generalized model, which will help us to do a better generalization for the incoming data, which is not seen during the course of training or during the course of validation. Okay, so in order to do that, if you want to prevent the problem of overfitting, then we can make use of the dropout. Like you can randomly drop out some of the neurons in the fully connected layer. Okay, so that is what a dropout function will be useful. And the dense layer is nothing but your fully connected layer, and then we have activation and then max pooling and then yeah, convolution 2D layer. And then there is a optimizers called Adam and Adamax. So if you let us say take an example of any of the neural networks. Okay, so let us take the example. I have values like this. So these are the, hope my Excel is visible to everyone.
Yes, sir.
Okay, so this is what I am expecting as the output of. Okay, so this I1 to I3 is the input and output is getting output I need is 30. Okay, but at iteration 1, so this is my inputs. Okay, so these inputs are multiplied with values like 0.1. Just it's an example. Okay, or you can consider 0.6. So the original value we need is 30, but we are getting, okay. So in the first iteration, this is that output I need, but after multiplying with, this is the weights, and this is the x, and this is your y. Okay, so we need output as 30, but after the first iteration I'm getting 8. Okay, so then we know that there is something is problem with respect to the model train. Then we need to back propagate this error. Okay, so how will you compute the error? So error is nothing but 30 minus, sorry, so error is nothing but 30 minus 8. So the difference between the original output and the predicted output is 22. Then we need to back propagate this error to the input layer. Okay, so in iteration 2, so x will be same like, but you can end up saying that there is some change that has been happening. So you can see the weights will be updated. Sorry. Okay, so now your error difference is 6. Okay, so basically what is happening is that, so we are back propagating this error to the input to update these weights. Okay, so this weights updation will be taken care of different optimization algorithms. One is your Adam optimization. Okay, so how this back propagation will work is that I think most of you are aware of chain rule, right? So the partial differentiation of chain rule. So if you want to correct y, so let us assume that this is I1, I2, and then I3, and this is y. So if you want to correct a y, then so I'm just giving dou. So dou of x divided by dou of, sorry, so it is dou y divided by dou x. Okay, so basically this is the partial differentiation of y upon x. Okay, so if you want to back propagate this error from y to x, basically what you are trying to do is, so dou of y divided by dou of I3, because y is depends upon I3. So then you need to back propagate dou of I3 divided by dou of I2. So similarly, so dou of I2 divided by dou of I1, and then it will be processed to dou of I1 divided by dou of x. Okay, so this is how the back propagation will happen, right? So it will start with at the output side, and then it will be end up to the input. Okay, so this will happen for each iteration. So let us assume this is iteration 1, and the weights you are getting is -1 comma -1 comma minus, sorry, zero point 0.1 comma zero point 0.1 comma zero point 0.6, and similarly for iteration 2, so your value is updated with 0 0.8 comma 0 0.8 comma 0 0.8, and then in iteration 3, so you will be getting 1 comma 1 comma 1. Okay, I'm just giving an assumption. It's not like you may end up getting this 1 comma 1 as a weights value at the iteration 10 also. Okay, so this is how this back propagation algorithm will work. So basically this back propagation algorithm will be taken care by this Adam and Adamax optimizer. So both are different optimization algorithm. Yeah, but this is the quick glimpse of optimizers. And then we have the metrics need to compute that. We have the categorical cross entropy. Basically, this is the binary class. You can make use of the binary cross entropy also, but and also we can make use of the categorical cross entropy. Okay, so the categorical cross entropy is nothing but it is a loss function which is help us to identify what is the loss, what is the loss between, or what is the error between the predicted probability and the actual prediction. That's it. Okay, so any doubts up to this? So then I am just exploring the file path, and then I'm reading some random images to do the visualization purpose. So if you take that, so the total training data set I'm having around 758 images, and test is 212, and then for validation I am having around 85 images. So then from this distribution we can clearly see that the data is not balanced in nature. Like if you take our ulcer, we are having a 409, and then for healthy skin we are having a 434. So basically we need to balance this data set in order to get the better results. Okay, so and also we need to address this class imbalance problem. So that's what we are doing is, so we are making each class to the maximum sample of 3000. Okay, so what we'll do is, so it will do some different data manipulations to make a 400 images to the 3000 images. So then at the end each class will have the maximum of 3000 images. Okay, so and then creating the training and test set. So basically whenever we are dealing with any data science model, we need to make sure that we are splitting the data set into three different sets. One is a training set, and then validation set, and then a test set. So this training set data will be shown to the model during the training, and then while we are validating the model, we can make use of this validation data set. While we are testing the model, we can make use of the testing data set. Okay, this ratios also depends upon the population of data sets you are having. If you are having a whole million records of images, Then you can go and having 95 percentage of training and 2.5 percentage for testing, and then 2.5 for validation. But if you're not having that much records, then you can have 70 for training, 20 for testing, and then 10 for validation. It's all depends upon the population of data you are having. Okay, so these are the some of the training example. Like you can see the normal images, and then we have abnormal image, some sample images from the data set, which help us to identify, okay, so this is what a normal skin look like, and this is how this abnormal skin look like. So then create a model using the transfer learning. So basically I'm not creating any model from the scratch. Basically what I am doing is I'm just taking some pre-trained model, which is trained on different set of images, and I'm going to make use of that particular model with the same set of weights, and then I'm going to fine tune the model at the output side, basically the fully connected layer, in order to make use of our own applications. Okay, so like the model name I'm calling is efficient net b5. So where I'm calling, so from the keras.application efficient net I'm calling this. So whether you need to include the top layers first, so if you want to do the model from the scratch, then you can include top equal to true. So the weights I'm getting from the ImageNet weights, like this model is trained on the ImageNet dataset, which is having around 1 million records with different set of classes. Okay, and then whether we need to train the base model, no, I'm not going to train the base model. Sorry, so I'm going to train the base model, like I'm going to train initial layers, basically it is a fully connected layer before the output layers. So x dot base model. So with the help of base model, I'm going to append some other extra layers. Like if you take, so this is the base model dot output. So we are getting that layers up to that base model, and then we are adding the batch normalization layer, and then adding another couple of dense layer with number of neurons is 1024, and then another layers with the number of neurons is 128, and then the final layer should be the dense layer again, and it should match with the class count. Here the class count is 2, so basically you will at the output of this particular output layer you will have 2 neurons with the activation of softmax. So if you consider this particular layers, the activation is relu, and here the activation is relu, because these two are the hidden layers, and this is your output layer. So basically what you can try to do is you can try to convert the softmax to the sigmoid also, because you know the sigmoid is basically used for the binary classification. You can make use of sigmoid function here as the activation function for the output layer. And then for compiling the model, we need to pass Adamax. Adamax is nothing but your optimizer algorithm. And then we need to pass what is your loss function. So loss function we are using is a categorical cross entropy. And then I am passing the metrics accuracy. So yeah, you can decide which metrics you need to focus. Like, so if you want to focus AUC, that area under curve, you can pass this area under curve. If you want to focus on the F1 score or precision and recall, you can pass that particular metrics in the model.compile line. So once you run this, basically it will download all these model weights or model pickle file from the Keras folder, and then I'm going to create a custom Keras callback that whenever we are seeing this validation or training accuracy is not progressing towards a good number, so either you can just stop training, or if you see that there is some progress is happening, then you can just continue with the training. So basically I'm just giving some intermediate alt between the training to understand whether that there is any progress is happening on the training accuracy and the validation accuracy. If there is no progress is happening on validation accuracy, so definitely I don't need to train this model for so long hours for the sake of training. Okay, so that's what I'm doing in this particular code. I'm just passing the alt command uh, to understand whether I need to continue with the training, or I need to stop the training. Okay, so Yeah, so for training the model, that the same command, whatever you are using the ML model, like model.fit uh, training generator, and then we need to pass epochs, and then callbacks, and then validation data, and then initial epoch. So basically the epoch start. So basically I have I have put the training for 40 epochs. I can see, so you can see that training accuracy and validation accuracy is making a good progress on the both the front. So that's what it is showing, that so your validation accuracies keep on oscillating between the values of 0.98, whether you need to consider, you need to continue the training or you need to stop the training. So what I'm going to do is I'm going to continue the training for epoch 20. So it will keep on it will keep training up to epoch 20, and then it will stop training. Okay, so meanwhile it is training. If you have any queries, so you can ask. So there is only a couple of things left. One is plotting this graph, and I think that I think most of the topics I have covered, what have it in my mind. So yeah, so while it is running for next 5 epochs, if you have any queries, you can just ask. We can discuss the queries.
Excuse me, sir.
Yeah.
Sir, in general, the neural network is applicable only for image processing or anyone that is for tuning your required value.
Okay, can you please repeat your question? That I know the
Yes,
first part, but I'm not able to get the
in
second part.
general, for the artificial neural network is used for image processing relevant terms, or it can be applicable for tuning a value.
Yeah. So can you just elaborate that which field you are working? Like then I
That
can.
is actually I'm working towards
Mhm.
for a closed loop function.
Okay.
I need to tune the value based upon the output.
Mm.
So the output will differ means my data is based on what to change the value.
Okay.
So what can I do for that? Just
So
like we are
basically,
using in our PI controller
yeah. So that's what I'm.
by changing the proportional or the integral control by tuning the value. So instead of using the PI controller, shall I
Mhm.
use the back propagation network by
Yeah,
tuning
we can do
my
that.
data?
You can make use of the grid search algorithm with the help of neural network. You can just pass whatever the numbers, like the numbers you need to pass.
Okay, okay.
Okay, so to fine tune this controller, then yeah, so make use of the neural network with the grid search algorithm, and then you can find what is the optimal number to make use of this PI or PID controller.
Okay, so just I am go for using either between 0 to 1.
Hmm.
Maximum value is 1, but in between maximum is zero point 0.4 to the zero point 0.7.
Yeah, so basically in the grid search, out how it will work, right? So we need to pass whether the grid search will be happening on a linear scale or in a log scale. Okay, so you can have the incremental number, like I have the range of 0 to 1 in the grid search algorithm, and then you can give the incremental number that, so this 0 to between the 0 to 1, it will increment up to 0 0.1, 0 0.2, 0 0.3, 0 0.4. So this grid search
Okay,
algorithm will take that incremental value and find out your output, what is the desired output, or what is the design number of optimal number of values that we need to consider for the PI/PID controller. Yeah.
okay, okay. So once I'm framing these rules by using a MATLAB software,
Mhm.
but how can it be implemented in hardware?
Yeah. So basically, if you want to embed this into the DSP control processor,
Okay,
so there is a different ways of doing. Like depends upon the applications. You can decide either you can make use of the NVIDIA Jetson Nano board, which is cost around 4K to 8K, depends upon the memory capacity. You can deploy that in the hardware, but and then another scenario that if you want to embed this into the FPGAs, so you can do that also. But the integration part will take some time, but we can able to do that. You can embed
okay,
this results the FPGA processor or in the DSP processor also.
okay, okay. Thank you, sir.
Yeah.
Thank you.
Any other queries from the audience side?
Sir, good morning, sir.
Yeah, good morning, ma'am.
Uh, Sir, I'm working in a project where we are identifying a particular animal or a plant using its image, sir.
Mhm.
Um, can I use this algorithms? What you have suggested, thought now, sir?
Yeah, we can use.
So,
We can make use of this transfer learning approach to solve any of our application.
collecting the theory information is possible with a journal or some learning materials, but working practically, like as you have done hands-on experience, you have shown many files. So, how to train ourselves in those manners? Only if we
Yeah,
train.
so maybe
Uh,
um, as a academicians, I know that what is the workload and what is the time we are getting to spend some time on hands-on, but I think you can spend some time on Kaggle platform because Kaggle platform is one of the uh, topmost data science platform to understand different applications. Like this is not only with respect to medical imaging, you will end up with seeing different like climatic change applications also there, and then forecasting also there, and then we have the text prediction. I
yes,
can make use of the Kaggle platform to explore different hands-on, like what are the steps we need to follow in order to get the results. Like if I want to do that, develop any data science model, what are the steps I need to consider to end up getting at the output side. Okay, so it is not only that getting the data from different sources and then directly passing the data to the model. It will not work out. So if you consider the
okay,
real time, we are not doing any this type of applications. Like we don't have any such data, that standardized data outside available in the market, and we can directly make use of in the data science model. So basically, we need to do different data transformation in order to get which are the better features. We need to better features. We are thinking that good to pass to the model. Okay, so make use of the Kaggle platform. I think you can able to do different hands-on by considering the different applications
yes,
out
sir.
there.
Okay, sir. Thank you, sir.
Yeah. Any other queries? So I have just entered the epoch up to 35. That's why it's taking time. So basically, instead of giving 5, I gave the output input as 15, though it is taking 20 plus 15, 35. So yeah, it will take next couple more minutes to complete. Yeah,
Sir, I have one doubt. I
yeah.
already asked regarding grayscale images like that.
Hmm.
If the transfer learning model uses the color image trained for color image,
Hmm.
if I have a grayscale image, say for example, brain tumor image,
Hmm.
so only grayscale image, how can I apply that model to
Yeah.
that input
So
image to?
yeah. So basically, if you want to make use of the efficient net for your own application, then so in the model phase where it's just give me a minute. Yeah. So you are mentioning this include top as false, right? Basically, you need to make include top as true, and then you need you need to pass that input shape. So in this input shape, you need to pass. Let us take an example. I have 224 class 224 grayscale image. Then I need to pass like this, like 224 comma 224 comma 1. Okay. So instead of passing input shape equal to image size. Okay, so basically how this is how it's working is it is considering like this. So 224 comma 224 comma 3 because 3 is the RGB image. So if you want to change this into your grayscale image, then you need to pass like this. Okay, and then you need to train from the scratch. Okay, so you need to change this include top to true. Any other queries?
So all the pre-trained model are only trained for color images only.
Yeah,
Is it like?
so it depends upon different sets. Okay, so if I'm the author of some particular network, but I have trained this model for trained this model for a different grayscale image, and then I have that pickle file, this model pickle file, and I uploaded in the GitHub profile. Okay, so you can make use of this particular pre-trained model, which I have trained for different grayscale, and make use of your own applications. Okay, it is not like that. This pre-trained model is only available for the color image. The pre-trained model is also available for the grayscale image. But we need to figure that out. Okay, which model is trained on color image and which model is trained on grayscale image, basically.
Okay, sir. So I have one more doubt, sir.
Mhm.
Is there any model trained for brain image classification, grayscale image,
Yeah, there is a
as
number
far as?
of models. So I think I also one paper on IEEE like where we are using this brain MR image for dementia classifications, where we have trained the model for grayscale only. We didn't use that converting that into color image, and then so we have used that same raw model, uh, so same deep learning model to train a brain image.
So you are trained from the scratch.
Yes.
Okay, okay. But it took long time to get trained.
No, considering the color image, grayscale image seems to be fast.
Okay, okay,
Considering the number of filters is very low.
okay. Thank you, sir.
Thank you. Yeah, so I think a model is completed. So we can plot the graph. Okay, so yeah, so this is the overall model accuracy, training and validation accuracy, and then model loss. And then, so we can also have the classification report to understand how the model is behaving like. Sorry, there is some underground library issue. Yeah, so this is ROC curve. So the ROC and AUC curve. The AUC curve is one, so which shows that the model is good in model predicting capability is good. Like so, it is correctly predicted all the abnormal images and also the normal images. Okay. So now this is a testing purpose. I'm just doing that explainable AI, integrating the explainable AI to the model. Yeah, I think I have done pretty much with the presentation and also answer. So yeah, if you have any queries, we can discuss.
Oh,
Sir, your mail ID, please.
I'm just posting the chat.
so what are the kind of softwares we can use, sir, for deep learning and machine learning? One is Google platform,
Hmm.
and the another is Anaconda.
Hmm.
So in Anaconda itself, bytes, Spider, PyCharm, like that available, or we can use different. It is different ID.
No, for
What
if
are
you
the?
take Anaconda Navigator, basically Anaconda Navigator will consider your local uh, RAM or local computing facilities. So if you want to
Okay,
train the deep learning model using Anaconda platform, it will take very good amount of time. Like
oh,
it will
okay,
take so much of time to do the computation. So
okay.
yeah, if it is a ML model, we can make use of the Anaconda platform. But if it is a deep learning, I'm not providing suggestion to make use of the Anaconda platform.
So it is better for deep learning model. Google platform we can
Yeah, maybe you
use.
can use Google Colab or Kaggle platform. Otherwise, you can just make use of some of the cloud service provider like Amazon, uh, so or Google, Microsoft Azure.
Oh,
Okay, so they will cost around $0.17 per hour. We can make use of our training purpose.
Google platform also like Google
Yeah, so
Colab.
Google Colab, we can't able to do continuous training on Google Colab, but in Kaggle
Oh,
platform we can able to do that. But both they having the time limited. Like if you take Google Colab, we can train up to 12 hours continuously, and Kaggle will
mhm.
provide only around 30 hours of GPU per week.
Okay, okay. Thank you, sir. Thank you for your rich information.
Yeah.
Any other queries from the participant side? Any queries from the YouTube live participants? I'm not getting any queries in the live chat. I hope there is no queries further from the participant side. Sir, shall we wind up?
Yes, sir.
Chandran sir? Yeah. Gayatri ma'am, are you there?
So she is in Viva, sir. View she is.
Yeah, okay. Shall we close, ma'am?
Yes, sir. Yes.
Yeah. So I'm glad to be here to express my vote of thanks on behalf of all. Thanks to our SVC management, secretary, principal, and HOD of the Department of ECE, Dr. S. Muthukumar, for their encouragement and constant support to organize this 5 days international STTP on advanced approaches and insights on artificial intelligence and deep learning in healthcare. A special thanks to our resource person, Mr. Chandran Venkatesan, for accepting our invitation and for sharing his hands-on knowledge today. Basics of CNN stages involved, a methodology of diagnosing diabetic feet ulcer using deep neural network, and live implementation of the same in Google Kaggle platform were delivered with better clarity, showing much patience to answer many more questions and queries from all the participants. And thanks to my fellow coordinators to convene the session successfully. And thanks to all the participants for your kind cooperation by making it as an interactive session. Feedback link will be provided shortly in Google Meet as well as in the uh, live YouTube channel. Please post it. Thank you once again, sir, for the crystal clear presentation. Thanks, sir.
Thank you so much, sir.
Thank you. Thank you. Thanks all participants. Please post the attendance, feedback, feedback come attendance.